Hello and welcome. Today we're going to take a look at Leetcode 42, trapping rainwater. This is an LC hard problem. Given n non-negative integers representing an elevation map where the width of each bar is 1, compute how much water it can trap after raining. And here we have an example with the map, with the elevation map, a bunch of heights, and the output is 6 total squares of rainwater. So 1 here, 4 here, and 1 here. And we can see that the trapped water at any given position in the array is calculated as the difference between the height of the barrier and the current height of the current position. And a key idea here is that the amount of water that can be trapped above a particular position depends on the shorter of the two barriers, the left and right barriers surrounding it. This is because water will overflow if one of the barriers is shorter than the other. Alright, so let's go and take a look at the drawing. So we're going to use 2 pointers, left and right, and we're going to traverse the elevation map that way. And we're going to keep a left maximum, a right maximum, and the total number of water trapped. And at each height, as I've said before, the amount of water trapped is going to be equal to the current maximum, so the left maximum on the left side minus the current height, which is going to be the height of the left pointer, and on the right side it's going to be the right max minus the height of the right pointer. So let's see how this works. At each position we ask, is the left height less than the right height? Well, yes, it is. So then we update our left maximum with the new value. If the current height is greater than the left maximum, we update the maximum. In this case, 0 is equal to 0, so there's no update. And we increment L. Alright, so now we ask again, is the left height less than the right height? No, it isn't. So then we go to the right side, and we update our right max with 1 because the current height is greater than what we started with, and we update our right pointer okay. And now, is the height on the left less than the height on the right? Well, 1 is less than 2, so yes. So we go on the left side and we update the max to 1 because our current height is greater than the current max, which is 0. So we update it to 1. And we increment left. Okay, then we ask again, is the left height less than the right height? Yes, it is. And our current height is 0, which is less than the maximum. So if it's less than the maximum, then we can trap water. And the amount of water we can trap is the left maximum, which is 1, minus the height, which is 0. So 1 minus 0, that means we are trapping 1 square of water. And we have to increment our left pointer. And now we're asking again if the left height is less than the right height, and both are 2, so no, it isn't. And we go towards the right side, and we update the maximum because 2 is greater than 1. We update the maximum, and we move the right pointer to the left. Okay, so we move the right pointer to the left, and now we ask again, is the left height less than the right side? No, it isn't. And also on the right side, the 1 is not greater than 2, so we can trap water. That will be equal to right max minus height of R, so 2 minus 1, so we can trap another additional square of water. So the total amount is now 2. Alright, and we move the right pointer to the left. Okay, so we have again, left height is not equal to is not less than right height because 2 is not less than 2. So we're going to update our max to 2, which it's already 2, and then we'll update it with itself, and then we move the right pointer to the left. Okay. And now, is the left height of 2 less than the right height of 3? Yes, it is. So we go towards the left side and we update the left max to 2. And we increment our left pointer. Alright, so is the current left height of 1 less than the right height of 3? Yes, it is. And also 1 is less than 2, so we can trap water in the amount of left max, 2, minus height, 1. So our water is now going to be 3. And we increment our left pointer again. And is our current height of 0 less than the right height of 3? So the left height of 0, is it less than the right height of 3? Yes, it is. And is the current height of 0 less than the max? Well, it is. So we are going to add the amount of water of left max, which is 2, minus height, 0. So we add 2 squares of water. So we have a total of 5. And then we increment our left pointer. We increment our left pointer. And then we ask, is our current left height of 1 less than the right height of 3? Yes, it is. And then again, 1 is less than 2, which was the maximum. So we can trap water in the amount of left max, which is 2, minus height of 1. That equals 1. So we add 1 more to 5, which means we have 6. And then we increment our left pointer so that both the left and the right are in the same position. And then the heights will be equal, so we go on the right side. We update the right pointer to position with index 6. So we are finished with the main iteration, and then we also update the right max to 3 because the current maximum is the largest, so 3. But we're finished because now R is to the left of L, so the right pointer is to the left of the left pointer. So we've traversed the whole array, and we found that our final result is 6. We have trapped 6 squares of water. Alright, so let's go to the code and see how this looks like. Okay, so we're going to use left max 0, right max is 0, water is 0. We're going to return water. And then we're going to have a left pointer and a right pointer. And while left is equal to right, if height on the left is less than the height on the right, we increment the left pointer, otherwise we decrement the right pointer. And here we check if the left maximum, if the current height on the left is greater than or equal to the left maximum, we update the left maximum. Otherwise, we update the water with the left max minus height of L, minus the height on the left side. And similarly, if the height on the right side is greater or equal to right max, then right max is height of on the right, equal to the height of the right, and otherwise we trap water in the amount of right max minus the height on the right. Alright, so let's see. Okay, the first test cases are accepted and accepted. And notice that this algorithm is has a time complexity of O(n) and a space complexity of O1 because we are not using any extra space. So time complexity O(n), space complexity O1. Alright, I hope you enjoyed this problem. If you did, like and subscribe, and stay tuned for more C++ problems. Thank you and bye.